Hello everyone, welcome to the final presentation of our Capstone project. Our project was the job tracker. I'm Hunter Evangelista, and this was also done with Asumi, Suzuki, and Mayaal. As I said, our team composes of us three. I know the project specifies having each team member do the presentation. However, our team is very distributed. Mayaal works off hours, and Asumi is located in Japan. So given the distributed nature, we decided to have one person go ahead and lead that, which is me. Our project is a job tracker, like I mentioned. It's a centralized, user-friendly web application that helps computer science students manage their job and internship entries, from applications to skills to networking, contacts, and we also provide an analytics page to track your progress. This is a really compelling application. It's really simple to use. The job application process, especially in this environment where the job market is so complex and there's so much ambiguity around the job search for today's computer science student, that having a centralized place where you can keep track of everything, make updates, track the companies that you have applied to, and see everything really easily with different charting is really compelling. There's dozens of roles that people apply to. You can see online where someone will apply to as many as 2,000 different job opportunities, and they'll usually use spreadsheets or really just like hodgepodge solutions because they don't have the time to create something like this that's programmatic. So we're providing that for them. Job Tracker helps them keep all job application details, associated skills, and contacts all in one place. We highlight insights with visual analytics, and we support students in staying motivated and focused during the job hunt. So what can a user do with the job tracker? They can create and manage job or internship entries with details like company name, role status, and notes. They can add and update the relevant skills with their name, proficiency levels, and provide descriptions to track what they've worked on and see improvements over time. They can also track the contact information of people they meet at networking events for different companies. They can tag them to different companies so they can see who they know at which company where they're trying to apply to a new job. There's also analytics, which provide insights through automatically generated charts, and there's the option to configure your own visualizations. We also provide secure authentication so the user doesn't have to worry about any sort of data leaks or hacks. So we use Google Firebase for this. So all private information that you register is stored with Google. There's nothing identifying that we store on our own servers. For development, Asumi was mainly focused on the front end. She led the front end development. She built our Next.js application. She designed our clean and user-friendly interface for all core applications. We used Next.js as our meta framework, and we implemented it with React, and we programmed it in TypeScript. We also used Zod for type safety and validating our data schemas. We used Tailwind CSS for the styles, and we used the Mantime component library for the pre-built objects. We also used Jotai for global state management in cases where it was appropriate, and we used Chart.js for data visualization. And we were able to enforce code style in our development environment with Prettier. We also used ESLint, which is not mentioned here. For the development, the overall steps were pretty straightforward. We set up the initial front-end environment and set up all the dependencies. Next.js is actually really helpful for that. It's a really easy install process, and you have a working framework of a web application very quickly. We created reusable UI components and designed the overall layout. She integrated form validation with Zod and managed state using Jotai. Styled analytic charts with Chart.js and created the initial framework for that. And she connected the front end to the back end for the basic CRUD operations. There were no major plans or no major deviations to the plans that we laid out. We had one major deviation from the overall team. We were a team of 4 and had to move down to a team of 3 for organizational reasons. There were some challenges. She was new to Jotai, Zod, and Chart.js. She really focused a lot on going through documentation and the examples that they have. All 3 of those technologies have really great documentation. There was some difficulty with the back-end integration. Like we said, we're we're a smaller team than expected, so we had less development resource on the back end. So there were some bumps along the way around integration with that. Asumi was known for what she learned, where she gained hands-on experience of Jotai, Zod, and Chart.js, improved skills in front-end architecture and component-based design, and learned how to integrate front-end with a fast API backend. Me, I was focused on full-stack development. My role, I primarily led the development of the application's deployment architecture and backend system. Also designed the analytics platform that allows for custom visualizations to help the user track their job search journey. Just going through the different technologies that I use for the deployment. We really used GCP for mainly everything. And the reason for GCP is because I find the user interface to be a lot more friendly than something like AWS. I've never used Azure before. So using a small provider wasn't really compelling because we wanted everything to be all in one place, so we weren't managing different service accounts and different deployment setups. So everything was focused on GCP. So our database was a MySQL implementation on GCP Cloud SQL. The backend and front end are deployed and hosted on GCP App Run, and that just is a managed VM that they handle, and you load your Docker image onto it. We use GCP Artifact Registry to maintain the image repository, and on push to our GitHub repository for the project, our continuous deployment will run, and it triggers GCP Cloud Build. The backend uses Fast API. Fast API is, to me, more compelling than Flask because it's a little bit more batteries included. Flask is nice because it is so bare bones, but what Fast API does is it is highly configurable, and it's not overly opinionated in a way that makes development feel like you're placed in a narrow lane, but it also has really interesting integrations for Pydantic, for your data modeling, and it's extremely fast. And it being so fast is really important to us because, one, we don't want to waste our users' time, and two, we're not using the most powerful deployment technology to keep costs down. So any latency we can make up by efficiency on the back end is going to help the overall user experience. For the analytics, like Asumi mentioned on her slide, we use Chart.js for the library, and we also designed a unique configuration pattern that allows the user to customize what they see. Development steps were, as you might expect, there was initial backend routing and business logic added in. This is all with hard-coded data. We deployed the database and designed a schema pursuing a third normal form, which just means that there's no intersection of logic. All relationships are implemented in an intermediary join table. So if you deleted the contacts table, the functionality of the application is largely going to work. You're just not going to be able to see your contacts. But the goal here is to provide a durable database platform that powers the application. After that, we built the analytics platform connecting the data that we had populated the database with, and then we connected the full stack application with authentication, and this is what allows us to track our users' actual information. Is what makes the app an app. There were no notable individual deviations from the main stories. Assistant authentication, I assisted on front end. I was pretty heavily involved in the whole application. The configuration for challenges and solutions, the configuration for Chart.js was really complicated. When you're managing the defined types, it's really easy to slip into development patterns that are unsafe and not taking advantage of TypeScript's type system. So it was a very concerted and intentional effort to design that part of the application to have it be safe. We wanted all of our errors to show up at compile time rather than runtime. This makes the application more durable for the user, and it makes it easier for us in the long run. What I learned is there were several times when I would finish a story, or I'd finish a PR, and I would go to deploy it, and there was an error. It really sucks to work on something like that and then have a completely different source of the project cause a bug. TypeScript's really nice. I've programmed in vanilla JavaScript before. Didn't really like it. I don't like any non-statically typed language, so TypeScript is a big solve for it. It's similar to why we use Fast API for the backend. Mayaal was mainly in charge of authentication. She used Firebase for it, so it was integrated onto the front and the back end. It was a pretty quick setup. The only back end integration that it needs is to get the identity token that Firebase sets. So you authenticate with Firebase, you get the identity token, you add it to your header, and then the backend has the needed information to decode it and get the actual user information. The development steps were set up Firebase project and configured auth via the Firebase console, create reusable auth components, login, register, auth, implement the email password sign-up and login flows, add a real-time authentication state listener to detect the logged in, logged out status, manage global auth state with Jotai, protected private routes using a higher order component that checks auth state before allowing access. That's just wrapping the component you would pass to the front end in a provider and checks for authentication. There are no major deviations, challenges, and solutions. Initially faced issues where the UI didn't reflect login state immediately. Solve this by wrapping Firebase's on auth state change and a use effect, listing it properly with Jotai state. That's a common use for a use effect as an escape hatch. Backend needed Firebase UIDs to link user data. I collaborated with backend teammate to ensure user info was sent correctly after sign up login. What she learned, mastered Firebase auth and how to integrate it into a Next.js TypeScript app. Learn how to protect routes and manage user sessions effectively in a React app. Enhance collaboration skills by coordinating with auth data structure with backend team member. Conclusion, future plans. We're graduating. There aren't solid plans for future development. For potential enhancement, there's integration with external APIs like Glassdoor or Reddit. There's improved UI UX for mobile responsiveness. And there's the opportunity to include more hate OS. You might notice hypermedia as a state of the application. Really what that means is when you make a request, we can provide additional information that allows the user to more dynamically move through the application. So there's some low-hanging fruit there, which would be nice to add and would be a very interesting enhancement. Just a disclaimer, this is not intended for commercial use, but is an effective demonstration, and it is usable for computer science to use and reduce the stress and confusion of the job hunting process. Given that, let's go ahead and do a quick demo. So this is the landing page for the job tracker. You can see you're just at the login page. You can't go anywhere else when you're not logged in. I prefer to use login with Google. It makes everything easier. I don't have to fill out my name. I don't have to do anything else. And I know that it's always secure. Please forgive me, my internet is quite slow. So we're going to go ahead and load everything. There it goes. So you can see I already have some applications rejected here. Well, let's just go ahead and rejected. Rejected. This is a work in process. So you can track everything here. You can go ahead and add a new application. So let's say I applied to Stripe, big company. And so I want a software engineer job, full-time, of course. Everything's on site these days, and I did it today. Status, let's say I applied. Notes. And you can see that's added right here. So we can see everything we added. You can see the skills that I have. So you can see me adding new skills. So let's go ahead and add Docker after this project. Definitely beginner. There we are. And you can see the contacts that we have, and then the different companies that we've applied to. And then there's also the analytics part where you can see some of the jobs that I applied to. Not a lot going on here so far. We can go ahead and add a few more. Let's go ahead and add one in like April and see it here. So we'll go ahead and so we go back to the analytics page. You can see now that it's present in April. If you want to add a new chart, you can add a chart with an X and Y axis, which we call 2 dimensions. And there's only one context available at the moment. On the X axis, let's see the status of all of our applications. And then we can also group it by company name. So we'll go ahead and create the chart. So we can see here that we were rejected from these companies, but also nice to know that we weren't rejected from Anthropic or Stripe, which is hopeful, fingers crossed. And then applied, and then work in process. And so you can continue to add charts. If you want a pie chart, you can do one dimension. And then we can go ahead and see different titles. So mostly the software engineer. So you don't want a chart, you can go ahead and delete it. And then that's it. Go ahead and log out. And that's it. Thank you so much for listening to our presentation. We hope you liked it. And yeah, take care. Thank you.